This honors geometry lesson on section 5.6 will cover proportional lengths in triangles. The objective is to state and apply the triangle proportionality and angle bisector theorem. Segment AC and DF below are said to be divided proportionally if AB over BC is equal to DE over EF. This leads us into our triangle proportionality theorem, or the side-splitting theorem, which states if a line intersects two lines of a triangle and is parallel to the third side, then the line divides the two sides proportionally. For the triangle at the right, the theorem tells us that A over B should be equal to C over D. This is just one of the proportions that we can conclude based on the side-splitting theorem. Here are two more that we could use as well. So we could take B over H and set that equal to D over K. Looking at the diagram, we can see that B represents the left side of the small triangle, H represents the left side of the large triangle. So we can set that equal to D, which is the right side of the small triangle, over K, which is the right side of the larger triangle. Another proportion we could set up would be A over H equals C over K. So A represents the bottom segment of the large triangle. H represents the entire left-hand side of the large triangle. So we can set that equal to C, which is the little segment of the large triangle, over K, which is the entire side of the right triangle. So remember, these are just some of the proportions that you can use that relates to the side-splitting theorem. Let's go ahead and take an example using that theorem. So at the triangle on the right, we're going to find the value for each ratio below that completes the ratio and makes them proportional. So if we have AB over BC, we can say that that is going to be equal to ED over DC. If we are given CB over CA, we can conclude that CD is going to be equal to, or I'm sorry, that CD over CE is going to be equal to CB over CA. If given AB over CA, we can conclude that that's going to be equal to ED over EC. At this time, go ahead and stop the video, take a look at the ratios, and make sure that you really understand why they are equivalent. For B, we are given that CB equals 12, and we are trying to find what AB is. So we're going to go ahead and call that X. So what we're going to do is set up a proportion. So what I'm going to do is I'm going to take CB over BA, which is 12 over X, and set that equal to CD over DE, which is 8 over 2. And then we can go ahead and use what we know about solving proportions and cross multiply. So 8x is going to equal 24. So x is going to equal 3, which means that AB is also going to equal 3. We're going to use the same information to go ahead and try to find AC. So for AC, we can go ahead and use what we know now. So we know that this equals 3. So if we add 12 and 3, we're going to see that AC is equal to 15. For example C, we are now given that BD equals 6, and we want to find AE. We're going to call that X. So if you notice, BD and AE are going to represent the bases of the small triangle and the larger triangle. So since I know the length of CD and the length of CE, which are the right sides of the small triangle and the large triangle, I'm going to use that in my proportion. So I'm going to take CD over BD, which is 8 over 6, and I'm going to set that equal to CE over AE, which is 10 over X. And then from here, we can go ahead and solve our proportion. So if we cross multiply, we are going to get 8x equals 60. And when you divide by 8, we're going to get x equals 7.5. So now we know that AE is 7.5. So the last thing we're going to do with this example is we're going to find the scale factor of triangle BCD. So BCD is the smaller triangle to triangle ACE, which is the larger triangle. So remember that the sides are going to be proportional. So if we take the right-hand side of the small triangle, which is CD, has a value of 8, and we take the length of CE, which has a value of 10, that's the large triangle right side, and we reduce our scale factor, so 8 to 10 is going to reduce to 4/5. So the scale factor from triangle BCD to triangle ACE is 4 to 5. So one of the corollaries that can be based on the side-splitting theorem states the following. If 3 parallel lines are cut by 2 transversals, then the parallel lines divide the transversals proportionally. This corollary will tell us from the diagram at the right that AB over BC is going to equal DE over EF. The triangle angle bisector theorem states if a ray bisects an angle of a triangle, then the ray divides the opposite side into segments proportional to the other two sides. So looking at the diagram at the right, the theorem will tell us that A over B is going to equal C over D. Let's take a look at example 2. A is going to be an example using the triangle angle bisector theorem. So we are given two triangles that are created by bisecting that angle. We know that the longest side of the large triangle is 20. The segment created on the left is x, so that means the segment on the right is going to be equivalent to 20 minus x. So using what we just learned about the triangle angle bisector theorem, we can take x over 20 minus x and set that equal to 6 over 9. Then from here, we can go ahead and cross multiply and solve our proportion. So we are left with 9x equals 120 minus 6x. If we move that negative 6x to the left-hand side, we're going to get 15x equals 120. And when you divide by 15, you're going to get a value of 8 for x. So now we know that x equals 8. And if you wanted to find the right-hand side, we can take 20 minus 8, and this side is going to equal 12. In the second example, we're going to use what we learned about that corollary based on the side-splitting theorem. So we are given that the segments on the left are equivalent to 10 and 15, and the segment on the top right is 14, and we want to find the bottom segment. So we can go ahead and set up a proportion and say that 10 over 15 is going to equal 14 over x. So if we solve our proportion, we're going to get 10x is equal to 210, and when you divide by 10, you're going to see that x equals 21. Okay, so here x equals 21. And for the last example, we're going to use what we know about the side-splitting theorem. So we are trying to find the left-hand side of the small segment of the large triangle. So we're going to have to make sure we set that equal to the right-hand side of the little segment as well. We're also given the entire left-hand side of the triangle is equal to 14, so we're going to have to use the entire right-hand side of the triangle, which we now know is equal to 16 based on the diagram.
Teachers and students.
So let's go ahead and set up our proportion. So we're going to go ahead and take x over 14 and set that equal to 6 over 16. So if we solve our proportion, we're going to get 16x is equal to 84. And if you divide by 16, x is going to equal 5.25. So now we know that x equals 5.25. For the last example, we're going to use the diagram at the right to fill in as many spaces as possible. So based on the first information, we are given that AR equals 6, that RT equals 4, that AN equals 9, and that TP, which is the bottom of the large triangle, equals 15. And they would like us to find AT, NP, and RN. So since AR plus RT equals AT, we know that 6 plus 4 is going to give us a length of 10 for AT. To find NP, we can use the following proportion. So we can take AR over RT, which is 6 over 4, and set that equal to AN over NP. So AN is 9, and NP is what we're trying to find. So if we cross multiply, we have 6x equals 36. So the value of NP is going to equal 6. Now we're going to go ahead and find the length of Rn. So for Rn, we can use the following proportion. We can take 6 over x, set that equal to 10 over 15. So if we cross multiply, we're going to get 10x equals 90. So x is going to equal 9. So now we know that Rn is equal to 9. And since we know that, let's see, AP. Oh, you guys. All right, so now what we're going to do is we're going to go ahead and find AP. So we know that AN plus NP is going to equal AP. So 9 plus 6 tells us that AP is 15. So now let's look at the second part of the information. So we're going to erase this. Okay. So based on the given information, we know that AT, which is this whole segment here, is equal to 33, that AN is equal to 24, and that NP is equal to 20. So let's go ahead and find AR. So for AR, we can set up a proportion of x over 33 and set that equal to 24 over 44. So I got 44, which is the length of AP, by taking 24 plus 20. So now we know that AP has a length of 44. Okay, and then from here, we can go ahead and solve our proportion. So if we cross multiply, we're going to get 44x is equal to 792. So x is going to equal 18. So now we know that the length of AR is 18. So to find the length of RT, we can take 33 minus 18, which is 15. So now the only thing that we have to find is Rn. So for Rn, we're going to use the proportion 18 over x and set that equal to 33 over 50. And when we cross multiply, we're going to get 33x is equal to 900. And when we divide, we are going to get a fraction, so we're going to reduce this as far as we can. And we're going to get 27 and 3/11. So now we know that the length of Rn is 27 and 3/11. This is the end of our lesson. If you have any questions, watch the video for a second time. If you still have questions, write down any of those clarification questions that you may have and bring them to the next class.